So in the topic of Laplace transforms, today we're gonna see the first shifting theorem and question and how to solve questions like this. So let us see first what the first shifting theorem is. So if Laplace of some function f t equal to phi s, this we already know, then Laplace of e to the power minus at f t becomes phi s plus a, and Laplace of e to the power at f t equal to becomes phi s minus a. This we already know, Laplace of f t equal to phi s. There phi is some function here. Here phi is some function. Then when there is a, so whenever we find anything with the e to the power something, that actually means that we can solve it with the first shifting theorem. So here in the example there is e to the power 4t sine cube t. So let's see how to solve this. Here we can relate with the definition here, definition of the first shifting theorem, that let's see that this Laplace of e to the power at ft, here ft it's a function. So when we relate with the question there, we can see that there is e to the power at, there is e to the power 4t, there is ft which is a function, there it is the function sine cube t. So first of all we have to find the Laplace of this function sine cube t. So let's see how to solve it. So we know the formula to find sine cube t. So the formula is 1 by 4 3 sine t minus 3 sine 3t. This is the formula. This is the formula from the previous classes. So now we have to transform it. Now the 1 by 4, this is the constant, it gets outside of the equation. Now we can see Laplace of 3 sine t minus sine 3t. We know Laplace of sine at here where a is any constant. We know this formula from earlier. So Laplace of sine at becomes equal to a by s square plus a square, where a is any constant. So when we relate this formula to this line of equation, we can see that sine t here becomes 1 by s square plus 1, and sine 3t here becomes 3 by s square plus 9. So further simplifying it, the 3 here collectively comes outside, and here it becomes 3 by 4 into 1 by s square plus 1 minus 1 by s square plus 9. It's all the formulas here, like this one, this formula, and this basic formula from the trigonometric equations, this trigonometric formula. So this is all that. Now by first shifting theorem, that is L e to the power at ft equal to phi s minus a. In this case it is e to the power at, because in the question there is no negative sign in the question. In e to the power, it is e to the power 40, not minus 40. So that's why we don't have to write this all the time. So by first shifting theorem, Laplace of e to the power 40 sine cube t equal to becomes 3 by 4 1 by s minus 4 square plus 1 minus 1 by s minus 4 square plus 9. Now we can relate with the definition here to understand it better. You can see that this a is some constant, this a is some constant. So here you can see we have applied this definition, e to the power at ft equal to phi s minus a. The phi here is the function, and s minus a we have to put it in here. We have to put it in this s's place. S is some variable, so we have to put the value in s's place. So like that it becomes s minus 4. Here you can see 4 was the constant, s is some variable, 4 was the constant. As you can see here, a was the constant, and it comes here as s minus a. Here a is the constant, you can see. So in our case also 4 comes here in this place, s minus 4 square, and whatever it was earlier, it was unchanged, but this value changes, s minus 4 square whole square plus 1 minus 1 by s minus 4 whole square plus 9. So by first shifting theorem we have found a solution to the question, that is e to the power 4t sine cube t. So whenever you find anything in power with e, we have to use the first shifting theorem. So now to explain the definition a little more better, let's take another example, example 2, where if we take Laplace of cos 2t sine t by e to the power t, and let's try to solve this with the first shifting theorem. As we can see, there is e to the power t, so we can guess that we can solve this with the first shifting theorem. So this equals to Laplace of, we bring this e to the power t. Let's see how we can change this. So e to the power minus t, this we know, cos, now the same cos 2t sine t. We only shifted e to the power t from the denominator to numerator. Now we can see L Laplace of e to the power minus t. Now we apply the formula for cos 2t sine t that we already know, that is half sine 3t minus sine t. So we did nothing but applied the formula. Now 1 by 2 here is constant, so we bring this out of the bracket. Now 1 by 2 of Laplace e to the power minus t, exactly same. Now sine 3t minus sine t. Now again equal to 1 by 2 of Laplace of e to the power minus t sine 3t minus e to the power minus t sine t. We just open the bracket here. Now let's see how we can go further with this question. So now here we have to find the Laplace of this sine 3t and sine t, which we know Laplace of sine 3t is equal to 3 by s square plus 9 square. That whatever that constant is goes in the numerator, and s square plus that constant square we know, and Laplace of sine t is equal to 1 by s square plus 1. So now by first shifting theorem, first shifting theorem, this becomes, from here 1 by 2 L e to the power minus t sine 3t minus e to the power minus t sine t becomes equal to 1 by 2 constant the same, and bracket 3 by s plus 1 whole square plus 9 minus 1 by s plus 1 whole square plus 1. That is the answer of the question. The question was cos 2t sin t et e to the power of t. So we know the e to the power t here, the e to the power at there, when there is positive in the power, this becomes phi s minus a. So here we can see e to the power minus t. Here when there is minus t, that becomes, when there is minus t, it becomes s plus a. So here in the answer of this question, it is here s plus 1 whole square and s plus 1 whole square. So what we have studied, what we have learned so far, let's quickly recap by these two questions. Here we can see the first shifting theorem. If L of some function equal to phi s, which you already know, then function, let's say L, when the function is there is the same, the function here is the same, but at the first place there comes a value e to the power something. Here when there is e to the power minus at, it becomes phi s plus a. In the place of the function, their value is s plus a when there is minus at. When there is plus at e to the power, that is e to the power at, it becomes s minus a. In the first question we have seen when there is e to the power 4t, when we solve this question, we first acquire the value of sine cube t, which is 3 by 4, 1 by s square plus 1 minus 1 by s square plus 9. So this is the function here, this is the phi. In this phi we have to put this value s minus a. The a is the power constant, the constant term with the power. Here the constant term with the power is 4. This is the constant term in the power. So let's see what happens now. So that you can see, when we relate to the definition, it becomes, we put the value in the phi, which is the function, this function. So here we can see now s minus 4 whole square plus s minus 4 whole square in this place. So this statement here, this whole statement here is the answer when we can relate with the definition. Here also, when there is L cos 2t sin t by e to the power t, when we put the e to the power t term in the numerator, it becomes e to the power minus t. Now see in this line we can see e to the power minus t, so it becomes s plus a, which is the constant. So we can see in the next page that it becomes 3s plus 1 square, but plus, because the minus is in the power, this add e to the power minus t. When this is minus t, it becomes plus s plus a in the phi value, that is in the function value. So here we can see the Laplace of this terms becomes this value 3 by s square plus 9 square, and Laplace of sin 3t, this sin t becomes 1 by s square plus 1 e to the power minus t. We have seen when there is this power, we have to use the first transform theorem, then it transforms into this statement 1 by 2. The e to the power values are now not, you cannot see them here because we have transformed it. So you can see this s plus 1 square, s plus 2 square. So this was all to solve the questions of first transform theorem.